Hi, it's Udeme Bere from DoLessons.com. In today's physics lesson, I'll be talking about motion. Motion is a relative change in position of a body with time. But we know that before there is any change in position of a body, there should be force. Now, we'll define force as any physical agency which tends or cause a body to move in a uniform straight line. Therefore, force is divided into two classes. One, the contact force and the field force. The contact force is one whose the body is in contact before the body is caused to move in a uniform straight line. Whereas field force is a force for which the body is caused to move by a physical agency without being in contact. Example of contact force includes push, pull, tension, and friction. Whereas the examples of force field include gravitational force field, electric force field, and magnetic force field. Now, in this particular area, motion, we will discuss the motion of a body as it moves without giving regard to what causes the motion. And this branch of physics is what we call kinematics. Kinematics. It is a branch of physics or mechanics in particular, for which studies the movement of a body without regards to what causes the motion. Parameters used in studying motion. We cannot talk about motion without recapping what we mean by vectors and scalars. Vectors and scalars. Vector quantities are those physical quantities with magnitude and direction. Example of vector quantities includes force, weight, electric field intensity, etc. And scalar quantities are those physical quantities with magnitude without directions. Example includes the area, volume, density, energy, etc. One of the parameters used in studying motion includes 1. Distance. Distance is a measure of length of a position of a body with regards with its initial point. That is, it is a length which is stretched out from between a position of a body from its initial and its final point. And its units will be given in meters. Other units will include kilometers, etc. And it is a scalar quantity, displacement. Displacement is a distance in a specified direction. You see, it will have a magnitude as well as direction. So therefore, we call it a vector quantity, since it has a magnitude and direction. So it is a distance of a body in a specified direction. We also have speed. Speed is a rate of change of distance with time. Speed is a rate of change. Rate is a rate of change of distance with time. It is a scalar quantity since it gives no regards to the direction for which the body is going. We'll also have velocity. Velocity is simply speed in a specified direction. Velocity is a speed in a specified direction. That is why it is a vector quantity. We also have acceleration. Acceleration. We define acceleration as the rate of change of velocity with time. So since velocity is a vector quantity, therefore acceleration is a vector quantity as well. Now, consider a body moving with initial velocity, u, with initial velocity, u meters per second, with an acceleration of a meters per second squared, covering a distance of s meters in time, covering a distance of s meters in time t seconds, with a final velocity u of v meters per second, Therefore, from the definition of acceleration, we see that a is equal to the rate of change of velocity with time. That is v minus u all over t. If we cross multiply, we'll have a times t equals to v minus u. And subject to rearrangement, we'll have that v is equals to u plus at. This is called the first equation of motion. Distance is equals to average velocity. That is the total distance covered is given as average velocity times time. That is, initial velocity here is u and the final velocity is v. So the average of that is v plus u all over 2. That is the average of that velocities times time. That is, distance is equal to half of v plus u times t. We can call this equation 2. Now, recalling from equation 1, that is, v is equal to u plus at. We'll substitute this in equation 2. Substituting in equation 2. Substituting in equation 2, we'll have that a is equal to half of v. Look at this. V is equal to u plus at. So I will put this value u plus at in place of v here to have u plus at plus this other u here, then times t. So I can now have that a is equal to half of, see, u here plus u here will give 2u plus this 80 times this t outside. Now, we'll use this t to open this bracket so that we'll have that a is equal to half of 2ut plus at squared. Now, multiplying through by half, this half outside here, you multiply through by half is to open the bracket. We now have that a is equals to ut plus half at squared. That is the second equation, the third equation of motion. See, when we multiply, these two will cancel out these two, remaining u times t plus this half times at squared gives us half at squared. Again, recall that v was equals to u plus at, or you can rewrite this as v minus u all over a is equals to t. That is from here. Make t the subject of the formula. You write it like this. You can call this equation star. Now, combining equation star and equation 2. Consider that is this equation and this other equation. These two equations. Now we'll see that the distance of the body is equals to u of v plus u all over 2 times t. Look at t here. Times t, which is v minus u all over a. Now, if we put this together, we have that s is equals to v squared minus u squared all over 2a. If you consider this in mathematics, this is difference of two squares. Now, multiplying through by 2a gives that 2a is equal to v squared minus u squared. Now, subject to rearrangements, we take this minus u squared to this side, so that we now have that v squared is equal to u squared plus 2a. And that is the last equation of motion. So therefore, if you want to calculate the velocity, the time, the acceleration, the distance, you can obtain that using any of these formulas. Thank you.